A connection pool shutdown is an error that stops a software engineering team. It indicates a system's communication has shattered. The conditions of this crash defied standard logic. A developer could click a button in the staging environment, and the application would process the request flawlessly. But the exact second attempt triggered an immediate collapse. If you ran the identical code on a local machine, it worked. If you ran it in the secondary testing cluster, it was stable. The evidence for this anomaly was buried so deep within the internal logs of the cloud infrastructure that a human would need days to manually untangle the threads. To accelerate the investigation, the team brought in an AI assistant. They fed it the complete stack traces, routing configurations, and infrastructure files from every environment. The AI identified that the staging environment was running a specific monitoring tool absent elsewhere. It proposed that this agent was interfering with background threads, causing a race condition every time the system tried to refresh its credentials. In minutes, the machine had cross-referenced every Helm chart, Terraform file, and SDK log to construct a theory that accounted for every environment variable. The theory was sophisticated, but it was wrong. The lead engineer felt a lingering skepticism about the AI's report. Instead of rewriting code to fix the supposed race condition, they paused the investigation to manually verify the server configurations. A basic logical inconsistency appeared. The secondary testing environment, which had been running flawlessly, also had that exact same monitoring tool installed. If the AI was correct, the testing server should have been crashing too. The AI had generated a plausible hallucination. It constructed a theory that matched the data points it favored, but failed a basic cross-examination against the testing environment's stability. By catching this inconsistency, the engineer redirected the entire investigation. They stopped looking at the cloud infrastructure and started looking directly at the application's source code. The actual cause was hiding inside a recent software update. The developers had migrated the staging environment to a newer version of their cloud connection toolkit. In the older, stable code, a single connection was established. When a user clicked, the packet was sent, and the connection stayed open for the next request. The updated code contained a flaw in its refactor. Every time a user clicked, it successfully sent the data, but it also spawned a brand new background connection that stayed stuck open. Because the system incorrectly believed it needed a fresh client for every action, these orphaned connections piled up silently with every click. When the user clicked a second time, the new request hit that tangled web of orphaned connections. They collided, and the system crashed. The older testing environment survived only because it ran the previous code version. The update introduced a latent defect that remained dormant until the staging environment's specific monitoring tools triggered the conflict. The AI didn't actually fail its assignment. It processed and correlated an overwhelming data dump at speeds a human cannot achieve. Even though its initial theory was incorrect, the AI's rapid cross-referencing eliminated dozens of potential infrastructure failures, narrowing the field of investigation for the human engineer. The machine provided raw processing power and massive synthesis. The human provided the judgment required to fact-check the logic. The resolution relied on machine speed to process the data and human judgment to reject the first plausible answer. As we move forward, AI is stepping in to clear out the days and weeks engineers currently spend on tedious, manual data sorting. It will eliminate the time spent staring at terminal screens, trying to find a single mismatched log entry across hundreds of files. But generating a plausible answer is different from verifying a correct one. AI handles the plausible. The engineers who thrive will use these tools aggressively, challenge their output, and rely on their own intuition to reach the right conclusion.